What's up, guys? So today we have a package in from a viewer. The viewer sent in two PS5s and we're going to take a look at them. So let me just get this package open. Nice, so they look well packaged. Looks like this one is a disc edition. So I'll just put that aside for a sec. Alright, so they both appear to be disc edition PS5s. I'm not sure if I'll do both of these PS5s in one video. I may end up only making one video unless they both end up being interesting repairs. Well, we will see. Alright, so this one says that the PS5 originally came with a broken power supply. It looks like they got it off of eBay. They replaced it and it worked for 2 weeks and then it just shut down during gameplay and never turned back on. He says he took the motherboard out and looked for a blown fuse or shorted cap. He couldn't find anything, and that thermal putty was replaced with thermal pads. So this one should be somewhat interesting. Let's go look at the other one. I will say that these are very well packaged, so huge props to the viewer who sent this in. Okay, so it looks like this one will boot loop on the splash screen. After a little while, it will work like it should until you go to play a PS5 game. He says also he removed the motherboard and cleaned all the thermal putty and liquid metal out of it. So I think what we'll do first is check out this PS5 that has the booting issues. So I can't seem to replicate the issues with this. I'm going to put this one aside until I get some thermal putty and liquid metal applied to it, because this one's just like behaving like a working console as far as I'm concerned. But I obviously believe the customer that there's something wrong with it, but I'm not comfortable testing it until we get some proper cooling set up for this thing. So let me put this aside and we'll look at the next console. All right, so I've got the other PS5 here. I'm just gonna plug it in and let's see if we get anything at all. So I'm gonna wait and I'll press power and we get no beep or anything at all, which is kind of unfortunate. So that means the south bridge probably isn't working and there may be a short somewhere. Okay, so I'm not gonna leave this plugged in because it's not exhibiting any sort of response. So this should be an interesting one. Let's get this opened up and see what we can figure out. Alright, so this one does have like a bunch of thermal pads, but they do kind of look thick to me. I think I'm going to replace these with proper sized thermal pads because, yeah, these are definitely larger than they should be. Alright, let's check what we're looking at resistance wise on the main power rail. So we do have a healthy 5.7 mega ohms there, which is looking good. So we're going to go to voltage and let's get a reading. Alright, so we are getting 12 volts from the power supply. I've got the motherboard out here and let's go ahead and take a look at the board under the microscope quick. And we can check a few of these fuses. So let's start with this one here. That one looks good. My cat is being a dumbass and he's trying to eat the tape on the box. My cat loves like adhesives and like tape and stuff like that. I don't understand what his problem is. No, I'm not gonna give you the tape back. He's going in the trash to get it. You have problems. I know. So sad. No tape for you. So we got that one there, which is good. That's also good. And my cat already got in the box. Anakin. You having fun? Oh, there is more tape. No tape for you. You can't have that. You're ridiculous. So yeah, let's go ahead and check some of these other ones here. That one is looking good. Okay, so the fuses are looking fine. Now I'm just going to check resistance to ground, all of these little voltage regulators here on the inductors. So these big, thick, like cap resistor looking things, these are inductors, and the output of these are going to be various voltage rails. So far they're looking pretty good. Let's check on Anakin. He's moving around looking for more tape to eat. Oh, and he's going to find some on the bubble wrap. God damn it. You have issues. Alright, so the next thing we're going to do is we're going to connect the board to a bench power supply. So I'm going to put my black lead on a little screw hole here. And then I'm going to connect this alligator clip to the positive lead. You can clip to both of these. I just find they're pretty close together, so I like to put them further apart like that. I've got my bench power supply here set to 12 volts with a 2 amp current limit. And we're just going to go ahead and turn this on. And we're going to check the standby boot sequence by monitoring the current draw right here. So we should see 12 volts when I turn it on, and we should see some amount of current being drawn. What we want to see is it go up to about 320 milliamps and go down to about like 7 to 10. So we're going to turn it on now. So we've got just straight up 7 to 10, and it seems to just like be cycling between 25-ish and 7. It's like continuously boot looping. So I'm going to turn off the power supply. All right, so after doing a little bit of research, the boot looping behavior we were seeing with the standby boot sequence means that we should check the 1.1 volt power rail for shorts. So we're just going to turn the board over here. All right, so I'm going to go into resistance mode. So I'll bring you under the microscope here so you can see what I'm looking at. We're going to go right over here, right under the south bridge, and we can check for 1.1 right here. So we're getting about 6.3 kilo ohms to ground, which seems seems fine to be honest. Alright, so next what we're going to do is we're going to monitor the board under a thermal camera. I'm going to be using this P2 Pro. So let's get the power supply hooked up again. Again, we have ground, and I'm just going to double check the ground connection here. With resistance mode, we'll go between here and here. And we should get close to 0 ohms, and we do. So that's good. You can't see that, but I've got it clipped on the bottom right there. So we are going to check with the thermal camera. And at this stage, I want to kind of just see what's going on when we apply power to the console in standby mode. So I'm going to turn on again. Again, we have the boot looping happening, and we can see a little heat spot on the south bridge right there. Can you see that? Let me zoom in with the macro lens here and see if we can't see that. I'm not sure that should be doing that. We don't see anything in the SSD controller region as far as I can tell. And a little trick when you're using the thermal camera is to keep your hand in the frame, because it makes it a lot easier to see heat spots like that. If I keep my hand out of frame, you can see everything's a little bit too bright and kind of the same color, but my hand is hot, so it provides a reference point for the thermal camera. You can also see all of the reflections and things on the board, which is kind of annoying. So that can kind of throw you off a little bit, but if you just move things around, you can see the heat spots on the power management IC here, and also the south bridge there are just sort of like stationary, even though all the reflections are moving around. So that can kind of help you figure out where the heat spots are coming from. Now, I do want to note that like these heat spots don't necessarily mean that we have a bad chip. It's just the chip is taking current for some reason. And right now it's just boot looping like a ton. So I'm going to turn the power supply off for a sec here, and we're going to flip the board and monitor one more time. See if there's anything on the other side of the board that's of interest when we apply power. So again, just going to keep my hand in frame and turn on the power. Really not seeing much going on here. Okay, I'm really not seeing anything on this side. So while this is kind of continuously boot looping, let's just check for a few voltage rails on this side. Check for the 12 volts coming in on the connector here. So we have 12 volts. Over here on this little point here, we should see 5 volts coming in, and we do. And then we should see on the inductor 2 volts, and we do see the 2 volts there. And then next we should have 1.8, which would be right up here. We do have 1.8. And the 1.1 volts here would only appear if we pressed power on the console. So let me flip the board one more time here. Okay, and we can come over here to this dialogue chip here. So here we should have a 1.9 volt output, and we do. We should also have a 3.3 volts, this inductor. Yep. Then here we should have 1.15. Here we should have 5 volts coming in, which you almost definitely do because it's generating those other power rails. So this is essentially like a multi-use buck converter. It's creating multiple voltage rails here. And I believe this pin here should be 1.8, and it is. So all of those are looking pretty good to me. So I'm going to go ahead and say the most suspect thing at the moment right now is the south bridge IC. Everything else sort of checks out as far as voltage rails go. All the fuses are good. It's just this weird like boot looping standby thing. So before I go ahead and order one of those, let me just flip the board quick and see what we have on the back of this here. So I've disconnected the power supply, and now I'm just going to be going through and checking in resistance mode. A few things are 8 ohms there. So that already looks pretty suspicious to me. This is a capacitor, so that's definitely ground, and then this is what, 8 ohms. That's like pretty low. Just gonna quickly grab the known working board here. I mean, we at least know the south bridge is working on this one, and I want to check the exact same capacitor, so we're just going to check here, and you can see we have a significantly higher resistance reading. You can see this is ground, and up here is giving us 26 kilo ohms. And that's definitely the exact same cap. You can see the layout is a little bit different on this one because it's a different revision. But if you look at the layout, like look at that, you can see that cap is smoothing that line right there that has the resistor above it. And then same exact deal here. So I'm pretty sure something is going wrong there because it shouldn't have that low of a reading. We can also check a few of these other capacitors here just to see. So 0 ohms there, and that looks a lot more like what I'd expect to see, about 10 kilo ohms. 3 kilo ohms on that side. I think I want to inject voltage just to see what happens. But first I want to check the other board here and just sort of see what kind of voltage I see when I plug this working board in. So I want to power this up with the bench power supply here. And we actually should see, if you look at the top left up here, the current draw, we should see a lot more around what we're expecting to see. It should go up to 320 milliamps and it should go down to about 7 to 10. And I'm expecting to see that on this board since it seems to boot pretty consistently. So as you can see, it's going up to about 300 milliamps and that goes back down to 7. So that's pretty much what we're looking for. And I want to check what kind of voltage we're seeing here. So we're actually not seeing anything here at all. Maybe turn the power supply on while I'm probing it. Maybe then we will get a reading. So I'm gonna just hold, I got ground set up on a separate area and I'm gonna hold this and we're gonna watch the multimeter. I'm gonna set the speed to high and then we're gonna press power on now. And we do see 3.3 volts here. So you can see when the south bridge has power going to it, there is 3.3 volts right there. And so that should absolutely not be such a low resistance on the other board. So let me disconnect this. We're gonna inject voltage really quick on that capacitor. So I've got the non-working or non-booting board over here. I'm also wanted to make sure that that voltage going through that area of the south bridge circuit wasn't under 1 volt. So I'm gonna set my bench power supply to 1 volt, 500 milliamps, and I will connect ground again here. And for the positive, I'm going to connect a little probe like this and just connect it just like that. Actually, you can't see that, but I've just plugged it in to my bench power supply just like that. And we're gonna come in here and I'm gonna be injecting voltage just right on this bottom of this resistor because that's where it connects to the capacitor. At the same time, I'll monitor under a thermal camera. So I'm gonna turn on my bench power supply. You can see 1 volt is on the lead and we'll carefully inject voltage right here. And it's taking 100 milliamps, 162 milliamps. What is taking that much current? Okay, on this side of the board, I just can't see. And I'm just gonna go out on a limb and say that it's very likely going to be our south bridge chip. But just to be sure, I'm gonna kind of put the board like this. You won't be able to see, but you'll at least be able to see the thermal camera on this side. And that's what we care about. So I'm gonna turn the power supply on again. And I'm going to carefully probe that exact same point. And there it is. You see that? See that heat spot? Very obviously a heat spot right there in the corner of the south bridge chip. I believe that's the south bridge chip. I can't see. Yeah, that is the south bridge chip. So if you just look here and I inject voltage again, look at that. It's just very obviously shorted. So this one is going to definitely be a south bridge problem. So I'm gonna let the customer know. I'll give them the price of the south bridge replacement and we'll see if they want to go ahead with it. And meanwhile, I've got some liquid metal coming tomorrow that we can pop on the other board so that we can test the actual fault of that one. So I will see you on the other side. Okay, it is the next day and we have some packages. One of these is gonna be a little ridiculous because there's a singular chip in here. I think this is the one that has just the south bridge in it, but we'll see. I think it's actually 2 days later. I ordered these on the same day, but they both came later than expected. Nonetheless, we have the chip here. So we've got the south bridge we can put on, and hopefully that will fix the issue for that console. And for the other one, we have some thermal pads and we have some liquid metal. I have thermal putty in stock, but I kind of wanted the little thermal pads and stuff. So I got these. These are 1 millimeter thick and are pre-cut and are designed for the PS5. So here they are. They're the perfect size. And I'll show you these in comparison to the pads they had on there. We also have various stencils here. So I got a direct heated stencil for the south bridge chip. So far for south bridges and stuff, I've just been using universal stencils and I'm done. I'm done using universal stencils. I like having the specific stencil for the chip, especially, you know, if it's one I'm doing often. So I got a south bridge stencil direct heated. I also got while I was at it, a SSD controller direct heated stencil. As you saw in my last SSD controller video, I just used a universal stencil for that one. But again, it'll be nice to have the one made for it. And then we have an SSD controller that I grabbed in case the other one that we're looking at has a bad SSD controller, because the symptoms of it kind of sound a little bit like that, even though I don't have any like error codes to back that up. I just wanted to have one on hand. And we have some liquid metal to use for the PS5, and I also got the exact same 2 stencils that I just showed you, but these are for the reballing jig I have in case it ends up being better to use actual solder balls for those, which I like to use solder balls for bigger chips. Here's my SSD controller stencil all taped off, but we'll be able to use this instead, which is just, this is just always so much nicer than having to deal with like the tape and shit. So yeah, so that's everything. I don't know what this is. They're sending me a thank you. No problem. So lots of fun little toys that should make our lives easier for these. Looks like we have some like crap that came off of the boxes. I swear UPS like rubs all of their packages in dirt before delivering them to me. Don't understand why. They're all so dirty. Yeah, I think this is gonna come with unleaded balls. It does come reballed. You know, since it's a smaller chip, well, small, it's not really that small, but it's smaller than the SSD controller. Let's give it a shot without reballing it with the leaded balls. I'm almost positive these are gonna be unleaded, but since the chip is sort of like medium sized and not like huge, I am comfortable just giving this a shot. I like to keep these anti-static bags for keeping parts and screws and stuff in, and need to like keep with the console while I wait for parts or things like that, so just nice to have. So let's put this south bridge back in this little container for now, and let me get the motherboard over here for the south bridge. Okay, so here is the motherboard that needs a new south bridge chip. You can see on this side, this is the one that has all those like thermal pads here. And let me take one of these and I'll compare these with the ones we just got, and you'll see why I'm concerned about these. So there are the pads that were in the console, and actually I do prefer thermal pads on these chips and things like that to this like little dot at the factory, but this is way too thick compared to this. So you can see this compared to our little things here that are the correct size. Just look at the thickness difference. It's like twice as thick there. So these 1mm squares that are designed for the PS5 are like twice as thin as the ones that are in there right now. And this thickness is actually misleading because there are little films that we need to take off as well on both sides. The problem is when you have thick thermal pads that aren't designed for the console, with all of the screws that are around this board between the sandwich of the heatsink and the metal shield, it's going to like put a lot more pressure than there should be on all of those chips, especially with thermal pads like these that really don't compress much. It puts like too much pressure on them. You know, especially when these VRAM chips get warm, you know, you can have issues like cracked solder balls and things like that. So you don't want to be messing around with thicker pads than there should be on the board. So anyways, on this console, we'll be replacing all of these with these for the VRAM. So it's time to replace this guy. So let's get this thing pulled off. So I'm gonna do my usual thing here with the hot air station. And I don't want to put this in a place that's gonna like smear the liquid metal around there. You like my little sticker I have on here? This, my wife actually made this for me. I'm really hyped about this. It looks so nice. Eventually I might make some shirts or something like the one I have on now, like this. And then the black one I had on for another video. So if you guys are interested in those, let me know. Alright, so there's the chip. So let me just start getting this thing heated. I'm just gonna go on the top and on the bottom like usual. And we're just starting at 200 degrees Celsius with max airspeed with no tip on the hot air station. Just gonna pop out the battery. And we can slowly start boosting this. 230 now, 260. As I always say, heat for a lower temperature for longer so that you can use a higher temperature for less time. Boosting it up to 300 Celsius. Starting to get hot, so I don't want to be staying in one place for a long time. Just keep things moving. And we're gonna add some flux soon as well. Once I get to 300, I like to add flux. So let me just do that. And we can go under the microscope. So I'm gonna add some flux around this just to promote the flow of solder underneath the chip. Cool, I'm gonna go up to 350. Just gonna grab some tweezers as well here with one hand if I can. All right, and the board is sufficiently preheated so we can go from the top. Cool, I'm gonna boost it to 425 now. And I'm just gonna continuously tap the corner of the chip like this just to see when it liquefies. And there it is, came off nicely. Just gonna add a nice chunk of solder, leaded solder onto my iron. just like that, big glob. And I'm not gonna touch the actual pads. I'm just gonna go around and mix the solder in and just allow the solder to touch the board, not my actual iron. So note that I'm not like scraping around with the soldering iron. And you can use a decent amount of heat for this because we're not directly touching those pads. So you can see all those pads are nice and shiny now. And as usual, I'm gonna cut a small bit of wick like this instead of a long one or using it off of a roll, because it's gonna be much easier here to wick this up. And again here, I'm really not putting much pressure. Like, you wanna use more heat here than you do pressure. And you wanna use sufficient heat so that the wick doesn't get stuck. Actually gonna cut an even smaller bit of wick. You can't make it too small because then it just gets like frayed. And as usual, tin your iron a little bit in between wicking sessions here because it will promote heat transfer between the wick and the iron. All right, and that's looking really good. And I do want to clean like as much of this flux off as I can, because the crystal on the other side of the board is very sensitive to flux underneath this chip. So crystals are one of those things that are kind of sensitive to extra flux and can screw with the oscillations and stuff, so it can cause problems. We are obviously still going to use flux to put the new chip on, but we want to use as little as possible in the middle there. And then I'm just going to rub this around with my pinky and just get a real thin layer spread out here on the pads. So we got the dot matched up with the little arrow there, and we've got all these little spaces matched up over here. So this is ready to go on. We'll just hang it off of the table again, and once again we're just going to start at 200 and get everything preheated. Actually, I forgot one very important thing. What's up, Anakin? What do you want? Are you hungry? I guess it's close to time to feed you. You're having a blast over there. Yeah, give me a sec. He loves the feeling of the cement, I think, on his back. Ever since we moved here, he's just been rubbing his back around on the cement like that. I was gonna say, I forgot to test the short. So yeah, exactly, Anakin. So let's make sure that the short is gone before we put the new chip on. Because if it's not, we're just complicating things. All right, so ground. And there we go, we've got 50 kilo ohms. I think it'll be a little bit less when we put the south bridge on, but our short is no longer present. So that is a good news as far as I'm concerned. So let's get this all back in position to get the chip put back on. Yeah, Anakin's hyped about it. Or he wants me to feed him, one of the two. I can't tell which one. Think it's gonna work, Anakin? That wasn't very confident. So I've got this board like somewhat preheated, and now I want to place the chip. So we're just gonna line this up on the pads, and as usual we're gonna put pressure down until it kind of moves around like that, and I'm pretty happy with that positioning there. So that's looking good to me alignment wise, and the board takes longer to preheat than the chip does. The chip gets hot real quick, but the board is big, has lots of surface area, and takes longer to preheat, so sometimes I'll preheat the board a little bit before putting on the chip. Just be patient with this stuff. There's really no need to rush and put lots of heat on the board and on the chip. You're only asking for trouble by doing that, so I'm just taking my time. I'm still at like 280, and we're going up to 340, 330. 336 to be exact. 370. Again, I'm cutting this long process out of the video, but between boosting temperatures and me telling you that I'm boosting temperatures, you know, I'm spending a good chunk of time preheating things. So I'm gonna go to 400 now. Some slower movements, but still keeping it moving. 430. And I'm just trying to find a good place to come in and tap test the chip. I don't want to like push around components, so I'm gonna come in from bottom right here and just give it a really light tap. There we go. That's all we need. I don't know if you saw that, but I tapped it like a tiny bit on the corner there. You really don't want to push it too much because you don't want those balls to bridge underneath the chip. We're actually going to do quite a bit of cleaning after this cools off underneath the chip, just to really make sure there's as little flux as possible under there. So let me go feed my like dying cat. He agrees. Something you'll come to know about my cat is he's never had food in his entire life. His owners are horrible and never feed him ever. Isn't that right? Yeah, you're miserable. No food ever. You're spoiled, Anakin. Alright, I'm back from feeding the hungry hippo. And this thing has cooled down nicely. So let's test for the short again. See what we get now. So black on ground and on the cap, 33 kilo ohms. That's much more like what we want to see. That's a lot better than 8 ohms. So we at least fixed an issue. To be determined if it fixes all of our issues. But what we're gonna do next is grab the tip of our hot air station. It's already at max airspeed, so we can just leave it there. And I'm gonna go to like 160 degrees. And what we wanna do is just run as much alcohol using something like this underneath the chip while kind of heating it to flush any flux that might be remaining in there out from under it. So we can just pop a little clean room wipe under there. Just gonna go like this. Gonna grab the hot air and just blast this chip with low temperature hot air underneath it as best we can on all sides. And the idea here is to sort of liquefy the flux as much as possible. I'm just gonna take the alcohol and just squirt it underneath. And I'm squirting it above so that it runs down the board underneath the chip. And we'll do one more round. Usually you don't want to be applying alcohol directly after applying hot air, but in this case it's a low enough temperature that it's not going to be problematic. But if you apply hot air like right after applying 400 Celsius, for example, you run the risk of creating microscopic fractures in the chip or in the solder balls. So don't just like shock the board with alcohol right after you're done applying lots of high heat. But low heat like this is fine. It's not going to be that big of a temperature difference. You have to keep in mind your alcohol is cold and obviously your hot air is hot. So you can cause problems. And we can dry the chip off. You really want to dry out from underneath the chip as much as possible, because the isopropyl can actually stay under there longer than you would think. You can see it's still drying. So that's where the high airspeed comes in handy, is it really forces air underneath the chip. Alright, so the chip's nice and cool now, so we can pop this battery back in and give this thing a test. Alright, so we're going to grab our power supply here and hook it up. I've got it set to 12 volts again at 2 amps. And we pray this time that we see a more normal amp draw. So what we're looking for is for it to go up to like 300 to like 320 milliamps and then go back down to like 7 to 10-ish milliamps. Cross your fingers. Hey, look at that. It's going up. 300 and going back down. So this is a really good sign. This means that we've successfully made it into the second stage of the standby power boot sequence. So the console's not on right now, but it did successfully go into like standby mode. So let me turn this off. And next step is to get this hooked up to the rest of the console. Alright, so I know I bought a capture card for this, but doesn't seem to like to work with PS5. But first, before I plug in HDMI, let's see if we get power. So I got power plugged in, and I'm going to press the power button now. Look at that, we got a light, and then we're going to get a white light. Look at that, that's good news. Okay, so I'll plug in HDMI cable while looking at the screen here. It's plugged in now, and with any luck, oh, I think it just went to sleep. Hey, look at that, good stuff, and it's complaining because we unplugged power. Amazing. So obviously we have to do some testing and just double check the functionality of this thing as a whole, but I'm going to call this one a fix. Nice and simple, just south bridge replacement, which is pretty common on these, but it was a fun way of diagnosing that one. Idiot. This is what my cat was eating, a rubber band. He loves rubber bands. Oh, he really wants it. He seeks out rubber bands. Look at him. No, you can't have the rubber bands. You're insane. You're gonna kill yourself eating these. Anyways, let's get these protective films peeled up and we can get this thing reassembled. Alright, so after some extensive testing, this PS5 is indeed fixed. The other PS5 has a whole host of its own issues that we will address in a completely separate video, because I want to make a dedicated video about that one as well. So keep an eye out for a video on that one sometime soon. But I'm happy we were able to get this one fixed. I appreciate you guys for watching, and I will see you in the next video. Peace.